Okay, so before we get into this lesson, just a bit of a recap of something from last unit. We spent a lot of time solving quadratic equations. So for example, let's say we got something like x squared plus 6 equals 5x. Okay, this could have been a typical type of question you would have seen, and in order to solve it, what you would have to do is get everything over to one side of the equal sign. So you would have gone and subtracted 5x from each side over here. Okay, and you would have gotten x squared minus 5x plus 6 equals 0. Okay, and then from there, your goal, since you had it all equal to 0, you would then factor it. And once you put it into factored form, you would then be able to get your solutions. So it's all equal to 0. You have your factored form, so you get your solutions being x equals 3 and x equals 2. Okay, which is all well and good, and everything that we were working with before, well, it was factorable. However, you get some situations where once you have everything over on one side that's equal to 0, your equation does not factor. So we need to find a way of getting the x-intercepts from there. You may remember from last year, if you were in the academic course, looking at something called quadratic formula. So in a situation like this, let's say you have something in standard form, ax squared plus bx plus c. One way of finding out the zeros or the x-intercepts is to use this formula right here. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, the values of a, b, and c come directly from the coefficients in standard form there, a, b, and c. Okay, so specifically, let's just say we had a situation like this. Let's say you're trying to solve the equation 3x squared minus 8x plus 9 equals 0. You can do a quick check here. You'll see it doesn't factor. If you wanted to factor this, you'd try and put it into an array here. And you'd try 3x squared. There's no common factor here. You'd have plus 9. And to fill in the other corners of the array, you would need two numbers that multiply to 27 and add to negative 8. You can try as much as you want, though that pair of numbers does not exist, so this particular one does not factor. Okay, so we'd have to use quadratic formula in this case. So if we want to identify the a, b, and c values, so once the entire equation is equal to 0, we can get our coefficients directly from the standard form. So over there, the 3 will be our a, negative 8 will be our b, and positive 9 will be our c. Okay, and then if we wanted to, we could use the equation to then solve for the zeros. In fact, let's go and do that. It doesn't ask to solve for the zeros, but let's go through it just so we can get an idea of how to use the equation. Okay, so let's write our equation out, and let's put in everything we know from the equation. So x equals, we have so b is negative 8, plus or minus the square root of negative 8 all squared minus 4. A is 3, and c is positive 9. Okay, and this is all over 2a, and a is 3. Okay, so at this point, again, this is an equation that will help us solve for the zeros or for the solutions to this particular equation. We can just simplify as much as we can and get our answers. So negative 8 becomes positive 8. Okay, underneath the square root we have negative 8 all squared, so remember the negative gets squared there as well, so that's 64. Okay, so 64 minus 4 times 3 times 9, 12 times 9 is 108. Okay, which when you simplify gives you negative 44. Okay, and your denominator down here is 6. And right away you're going to see a little bit of a problem here. If you try to simplify this further, you're going to see that the square root of negative 44, which if you try on your calculator will tell you it doesn't exist. You cannot take the square root of a negative number. So we have a situation here where what's in the square root is negative, we can't get a solution. So what does it actually mean? Well, if you look back at the original equation, this part underneath the square root, b squared minus 4ac, has a special name. It's called the discriminant. And it says underneath as a little note here, has no solution if negative, which in a way kind of makes sense, because you can't take the square root of a negative number. If you get a situation like this, it must mean there's no solution. Let's just see what this means in terms of the actual equation and see if this actually makes sense. Okay, so we take a look at the graph on Desmos. Here's 3x squared minus 8x plus 9. Remember, we're trying to see where it was equal to 0. Well, if you look here, it's never equal to 0. Okay, there's no zeros to this equation. The parallel is completely above the x-axis. So that's why this one has no solution here, because again, there are no zeros. So when you get a situation like this, what we're just going to say is that there is no solution. Okay, so the discriminant is negative. What that is telling you is, again, that there is no solution. So this particular one has no answer, but again, in general, if the discriminant is not negative, we should be able to use this to solve for the zeros. Okay, let's take a look at a few more examples. Okay, so remember, just as a reminder, if you're trying to solve a quadratic equation, this is the exact same stuff we went over last unit. If you're trying to find the zeros and it's in factored form, you can just get the zeros from each individual factor. So again, let's say you have y equals negative 4, x minus 6, x plus 2. Okay, you'd be able to tell me pretty quickly that your zeros are at x equals 6 and negative 2. Okay, if you're in standard form, what we would then do is, last time we tried to factor it first and then put it in a factor form so we could get the x-intercepts. Now we have another option. If it doesn't factor, we can use quadratic formula to get the zeros. Okay, the other option we do have is to use completing the square to put it into vertex form and then find the zeros from there. How do we get the zeros from vertex form? Well, vertex form is nice because there's only one x inside the equation. So let's just say we had a situation where we had f of x equals 2 x minus 9 squared minus 6. In theory, once we set y equal to 0, rearrange the equation and get x by itself. That's how we would have done that last unit. But again, now if something doesn't factor, we can use a quadratic formula. So let's take a look. So here's a situation. We've got a height in meters of a ball of the ground can be modeled by h of t equals negative 5x squared plus 2x plus 4. Okay, so we already have a little communication area here. It's h of t. T should be an independent variable. So let's just change these to t. Okay, and t is in seconds. So it wants us first to determine the initial height of the ball, and then when the ball hit the ground. So let's take a look at the graph first. Okay, so the initial height of the ball. So think of that word initial. It means no time has passed. So looking for the point where t is equal to 0. So where t equals 0, you can see on the graph it happens here at the y-intercept. So the answer is going to be 4 meters for the initial height. So to actually solve it, what we could do is, again, sub 0 into the equation for t. So we get negative 5 times 0 squared plus 2 times 0 plus 4. Okay, which gives you 4 meters. Okay, and again, if you also recognize the initial height is talking about the y-intercept, you can pull the y-intercept directly from the equation and get your answer being 4 meters. Okay, as for when the ball hits the ground, well, that's a little bit different. Let's go take a look at our graph. So the ball hit the ground when the height is 0, and you can sort of see from the graph two approximate answers here. We have 1.117 seconds and negative 0.717 seconds. Now the negative one doesn't make any sense because you can't have negative time, but at the very least from the graph we can see the two spots where this graph crosses the x-axis. How do we solve that? Well, you can try very, very quickly to find the zeros, this one, by factoring, but once you try, you'll see this one does not factor, so we have to use quadratic formula. So in this particular case, if we're going to use quadratic formula, okay, we have to identify our a, b, and c values. So in our equation up here, our a is negative 5, our b is 2, and our c is 4. Okay, so with that in mind, let's actually try and sub everything into the equation and find our zeros. So we're going to have negative 2 plus or minus the square root of 2 squared minus 4 times negative 5 times 4. And the denominator is 2 times a, so 2 times negative 5. Okay, so I'd like you to try and simplify this as much as you can on your own first. Okay, so give that a try. I'll work along it with you here. Okay, the discriminant, so that part under the square root simplifies to 84. Okay, and the denominator becomes negative 10. So in theory, again, these are both answers right here. So remember, because we have the plus or minus, it means two possible things. It means that x equals negative 2 plus the root of 84 all over negative 10. Okay, or we have the other possibility, which is x equals negative 2 minus the square root of 84 all over negative 10. Okay, so these are the two answers in exact form. Now, again, this is a real-life problem here with, real-life variables such as time and height. So we should solve for each time to make sure that they're admissible. Now, we already saw from the graph that one of them won't be admissible, but let's actually calculate them here. So let's run both of these through our calculators, okay, and try them to make sure you can get your calculator to work as well. So for the first one, negative 2 plus square root of 84 divided by negative 10. This gives you approximately, to 2 decimal places, negative 0.72 seconds. And the other one gives you approximately 1.12 seconds. Okay, so looking at both these answers here, you can say that this one is inadmissible. Okay, because time can't be negative, so t has to be greater than or equal to 0. Okay, so it means the ball is going to hit the ground after 1.12 seconds. Okay, so let's keep going. So here's one. It's just a straight up function, and it wants you to find the zeros. So remember, if you want to find the zeros, it means you're setting y equal to 0, the whole function equal to 0. So you have 0 equals negative 3x squared minus 24x plus 17. Okay, and you need to, again, find the zeros. Again, always check to see if it factors first, because it'll be a little bit faster using quadratic formula. Once you find out that it doesn't factor, go ahead and use quadratic formula. So there you have it. I want you to try this one on your own. So figure out what your values for a, b, and c are, sub them in the equation, and try and solve for x. Okay, and when you're finished, push play, and we'll go through it together. Okay, let's take a look at our answers here. So again, in this particular case, a is negative 3, b is negative 24, c is 17, comes right from the coefficients from standard form. So I plugged those into the equation, simplified as much as I could. So negative b is negative 24, which is positive 24. Everything underneath the square root simplifies to 780. So remember, when you're squaring negative 24, you square the negative as well. Okay, that's a common mistake that tends to get made. And then I have negative 6 in the denominator. So I split it up into two different calculations. So one where it's 24 plus root 780 over negative 6, the other one where it's 24 minus root 780 over negative 6, and found both possible answers there. There's no real life situation here, no restriction that says that x can't be negative. So these should be our answers. Let's just check our graph here. And here it is in Desmos. You can see the x-intercepts at negative 8.65 and 0.65 approximately. Okay, so let's take a look at one more here. But first, before that, just a reminder, and again, this comes right from last unit. If you have a quadratic equation that's not already equal to 0, remember that we made it equal to 0. We brought everything over to one side of the equation, solved for x, and then, once it was all brought over to one side, we'd solve for x by factoring the last unit. Now we can actually, again, use quadratic formula. The only exception to this was, again, if it was in vertex form, there's only one instance of x, you can rearrange the equation and solve for x. You could always expand and simplify to put it in a standard form, but that usually takes much more time. So again, always look for the most efficient way of solving. So with this one here, we're given two different functions. So f of x is 2 bracket x plus 4 all squared minus 5. It's in vertex form. And g of x equals x plus 4 times 3x minus 1. And it says solve f of x equals g of x. Okay, there's a lot of notation going on here, and remember, we have to get used to working with the function notation in grade 11. So remember, it says solve f of x equals g of x. Let's just set up that equation first. So f of x is this. Okay, and we're trying to solve f of x equals g of x. So there's f of x. Okay, and that needs to be equal to g of x, which is over here. X plus 4, 3x minus 1. So what we have here is a quadratic equation. You see it's not equal to 0 yet, because we have things on both sides of the equations. What we want is to have this equal to 0. So think about how you can get everything over on one side, have it equal to 0, and we'll finish this up in part 2 of the lesson. Okay, we'll see you over there.